Here we are looking at the vertex of parabola. So a vertex is the turning point of a quadratic function. So that vertex could be one of two things. It can be a maximum point when we have a value, when our a value, the value coefficient in front of our x squared, when it's less than 0, otherwise also known as a negative number, we have a concave down graph. So because it's concave down, our vertex is a minimum, or I'm sorry, is a maximum. Okay. The other scenario is when our a value, okay, is a positive number, it's concave up. And because of that value, okay, we end up getting a minimum value. So we'd have a graph like this, okay, and down here, that would be our vertex, the minimum value of that quadratic. Okay, since the vertex lies on the axis of symmetry, okay, we took notes on, we can find negative b over 2a, that is equal to the x value of our vertex. In order to find the y coordinate, okay, we can substitute that back into our original equation and solve for our y once we have the x value of our vertex. So let's look at an example here. Consider this function, y equals negative x squared plus 2x plus 3. So what I want to do is I'm going to go through all these steps in order to really get a good graph over here of my function. So find the axes intercepts. Okay, so find the axes intercepts. I notice this is in standard form, so it's going to be easiest to find my roots. So I'm going to factor it. Okay, so because they're equal, I have a negative x squared, so I have y equals negative x squared plus 2x plus 3. I don't like this negative here when I'm factoring, so I'm going to just factor that out. So I get negative 1. I'm left with x squared minus 2x minus 3. I'm going to try and factor that. Okay, so again, thinking of my factors, I want things to multiply to negative 3 and add to negative 2. So I'm going to get a negative 3 and a positive 1. They multiply to negative 3 and add to 2. So therefore, my factorization is going to look like this. Negative 1 times x minus 3 times x plus 1. Okay. So, in order to find my zeros, okay, I get my roots here. From this one, I get x equals 3. From this one, I get x equals negative 1. So I'm going to go ahead and graph those. So x at 3 and x at negative 1 are my roots. So I've done part A. Part B, find the equation of the axes of intercepts, okay, or the axis of symmetry. So remember from our previous slide, we know that our line of symmetry is equal to x equals negative b over 2a. Well, my b is there, so I have negative 2 over 2. And my a value is right there, so it's negative 1. So I get negative 2 divided by negative 2, which is equal to 1. Okay, so my axis of symmetry is x equals 1. Remember, it's a vertical line. So typically, I like to do it as a dashed, okay, line. It should make sense. It's in between my roots. To the right of my axis of symmetry, to my root is 2, and to the left of it, my root is also 2. So it's right in the middle. Okay, so I have completed part B. Find the coordinates of the vertex. Well, I know the vertex has to lie on this line, which is x equals 1. So I can plug that into my function. Okay, so I'm going to get y equals, so this is for part C, y equals negative, well my x is equal to 1. So I have negative 1 squared plus 2 times 1 plus 3. And then simplify. So 1 squared is 1, but it's opposite. So I do negative 1 plus 2 plus 3, which is going to be equal to 4. So that's my y value. So therefore my coordinate of my vertex should be an x value, which is 1, and a y value, which is 4. Okay. So the last piece is to sketch those things. So I'm going to go ahead and sketch my vertex at 1, 4. Okay. So I have all those 3 points. Okay. I also want to find, I missed a step here in part A. I found my x-intercepts. So these are my x-intercepts. So my y-intercept, remember, is my c value. So my c value is 3. So y equals 3 is my y-intercept. Okay. So now that I have all those, I can connect all the dots and construct my parabola. So I'm going to have it going through my root, crossing my y-intercept, turning point at my vertex, and coming back down. Okay. I know it's concave down as well because my a value is negative. Okay. So that's how that looks there. Let's look at one other example here. So this one's nice because it's already in factored form, so it's easier to identify my axes intercepts. So for my x-intercepts, okay, it's where it's equal to 0. So y equals 2 times x minus 2 times the quantity x plus 4. What makes 0? Well, that's when x is equal to 2. What makes this 0? When x is equal to negative 4. So I can graph those points at 2 and negative 4. Okay. I can find my y-intercept. Okay. Well, I don't have a c value because I'm in this format. But I know y-intercepts happen when x is equal to 0. So I can plug that in. So I get y equals 2, 0 minus 2 times 0 plus 4. This is equal to 2 times negative 2 times 4. So I get negative 2 times negative 2. It's negative 4, and this is going to be negative 16. So I'm actually going to be way off this graph, somewhere down here at negative 16 as my y-intercept. Okay. So next, I'm going to find the equation of the axis of symmetry. Well, this one I don't necessarily am going to use my equation, but I know that the axis of symmetry needs to lie in the middle of my two roots. So in the midpoint of 2 and 4, so I do 2 plus negative 4, okay, and I divide it by 2. So I get negative 2 divided by 2 is equal to negative 1. So this is my axis of symmetry. So at negative 1, I have, and it makes sense because it's 3 to the right, to my root, and then 3 to my left, to my other root. So my axis of symmetry is there at x equals negative 1. Okay? So x equals negative 1 there. Find the coordinates of the vertex. Well, again, the vertex has the same x parameter as my line of symmetry because it goes through that point. So I'm going to plug that into my function. So I'm going to let x be equal to negative 1, and I do y equals 2 times negative 1 minus 2 times the quantity of negative 1 plus 4. Okay. So I get 2 minus 3, negative 1 plus 4 is going to be 3. Okay. And I'm going to get negative 18. Okay, so then if down here I made this negative 6, 2 more, just extending this axis at negative 18 and negative 1, I'm going to have my vertex there. Okay. Now, again, to sketch my graph, I'm going to put all those things together. Okay. I know it's concave up because my A value is positive. Okay, so my vertex is here. I'm going to cross my axis here. I'm going to go through my root and then continue on to infinity, and then symmetric on the other side of the graph. Connect there, and I get my parabola. Okay, that concludes our notes for tonight. Highlight any questions you might have and bring them to class tomorrow.